Let's talk a little bit more about the graphs of these higher degree polynomial functions. And a big thing it's going to want to know is either how does it end or does it have a positive or a negative leading coefficient? So how can we tell? It says if a polynomial function has a positive leading coefficient, and so remember that leading coefficient is the number in front of my highest degree. So usually what's the first term in front of these polynomials? Is it positive or is it negative? If we have a positive leading coefficient, then the graph ends tending upward. So it will end going somewhere in an upward trajectory. If I have a negative leading coefficient, then the graph ends trending downward, so going down in some kind of downward trajectory. Now, the two types of higher degree polynomial functions that we're going to be focusing on in this section and next section, well, even third lesson as well, are cubic and quartic functions. So let's go over these. A cubic function and the variable x has this form right here where a cannot equal 0. So you have ax cubed plus bx squared plus cx plus d. So what is the degree of a cubic function? Well, that highest degree is 3. So that tells me my zeros or x-intercepts at most can be 3, and which means I have at most 2 turning points. So let's just stop right there for a second. I have some possible graphs here. And so again, keyword is possible. This isn't what they're all going to look like. And so you can see it doesn't have any x-axis. We can't see how many times it's crossing that x-intercept. But if we focus on these at most 2 turns, you can see this one here has 1, 2 turning points. This one here has 1, 2 turning points. This one almost looks like it really just has the 1 turning point right there and right there. So it could have at most 2, okay, but it could have 1 as well. That leading coefficient of this right here is going to be whatever this a is right here. So, and what I mean by a is whatever's in front of this x cubed term. My leading coefficient will be a. And if we look at those leading coefficients, when I have a positive leading coefficient, notice that these should be ending going up. When I have a negative leading coefficient, these cubics are ending down. What happens with all of these end behaviors, whether it ends up or ends down, they start and stop opposite. Okay, so what I mean by that is when it ends going up, it starts down. When it ends down, it begins up. So this is how you can easily tell that it's a cubic, that they're going to be at odds with each other on those starting points. Now my quartic function and the variable x is in this form here, where again, a cannot equal 0 because it's going to take away that x to the 4th. And so now I have ax to the 4th plus bx cubed plus cx squared plus dx plus e. So what is my degree here? My degree this time is 4 because that's my highest exponent, which tells me I have at most 4 zeros or x-intercepts. And I have at most 3 turning points. That's your n minus 1. So pause there again. I, again, don't see x-intercept, so I can't really show you this one here, but I can look at these turning points. If you notice here, we have 1, 2, 3 turning points. That's the most it's going to have. We've got 1, 2, 3 turning points. Here is still 1, 2, 3 turning points, but these turning points are very, very shallow. But these can also look like this right here, which this looks almost more like a parabola, right? Right here. And so it could have as least as 1 turning point. So what is its leading coefficient? Well, it's still going to be this a right here. Okay, and so even though these both have a, what a is representing on this one is what's in front of that x to the 4th. What a is representing here is what's in front of that x cubed. And so if we pause there again, if I have a positive leading coefficient, it should be ending up. If I have a negative leading coefficient, then these are all ending down. Now let's look at this end behavior, because this end behavior and this end behavior is how we're going to be able to really tell if it's a cubic or a quartic. When I have an end behavior of a cubic, they're going to start and end in opposite directions. So if it starts down, it ends up. If it starts up, it ends down. But with all of these all start and end together. So if we have a positive leading coefficient, meaning it ends up, it also always starts up. If I have a negative leading coefficient, it ends down, but that also means these all start down. So they will either both start and stop up or start and stop down. Okay, so let's apply this here. Turning to the next page, we have example 2. Example 2 says, use the given graph of a polynomial function to estimate the x-intercepts. So where is this crossing my x-axis? We have one x-intercept right here at x equals -2. And we have another one right here at x equals 3. So now state whether the leading coefficient is positive or negative. If it is positive, then that graph ends trending upward. This is not trending upward. This one is trending downward. So it must be negative. So we have a negative leading coefficient. If you want to just leave it like that, that's fine. But I'm going to put because it ends down. You can see that right there. Okay, so that's how I know it's negative. And then determine whether the polynomial function is cubic or quartic. Okay, and to be able to tell the difference, we're looking at its end behavior. Does it start in opposite directions or does it start and end together? And this one both starts and ends down. It looks very similar to this one right here. So this one would be a quartic. Okay. Example 3, exact same things. Estimate the x-intercepts. So we have one here, here, and here. That's where it's crossing the x-axis. So notice I'm not including this 4 right here. That's a y-intercept. I need just x's. So x equals -2, 1, and 2. State whether the leading coefficient is positive or negative. Okay, it's positive if the graph ends trending upward, which is what we have right here. So this one is positive because it ends up. Determine whether it is a cubic or a quartic. That comes from this end behavior. Because this end behavior starts opposite, meaning one is up and one is down, that makes this one here a cubic.